Okay, good morning, everyone. I'm Yuzuko Hosoya. This is my first time joining Postgres Open and giving a presentation. But I'm really glad to be here now. Today, I'm going to talk about hypothetical partitioning for Postgres, which is a new function of Postgres extension, HypoPG. If you have any questions, please save them until the end. Okay, let's start it. First of all, let me introduce myself. My name is Yuzuko Hosoya. I'm from Tokyo, Japan. Yuzu is a citrus fruit and often used to flavor in Japanese cuisine. I have been working for NTT Open Source Software Center for about 2 years. Nowadays, I'm working on developing HypoPG and interested in prana and partitioning. In my free time, I do dancing and go on stage once or twice every year. Today, I'm going to talk about these topics. At first, I will give a brief introduction of HypoPG. Then, I will explain why I'm working on hypothetical partitioning function on HypoPG. Next, I will show you HypoPG's usage, architecture, and demo. At last, I will talk about future works and summary of my presentation. At first, I'm going to introduce HypoPG briefly. HypoPG is one of the Postgres extensions. The first version was released in 2016 for the purpose of hypothetical indexes. The latest version is HypoPG 1.1.2 and is compatible with Postgres 9.2 and above. And I'm working on hypothetical partitioning, which will be a HypoPG's new function with the author Julian. The current version, HypoPG 1, supports hypothetical indexes, as I said. It allows users to define hypothetical indexes on real tables and data. And then, if hypothetical indexes are defined on table, prana considers them along with any real indexes. After that, it outputs create plan and cost with explain statement, as if these defined hypothetical indexes actually existed. When you create new indexes, you don't know whether Postgres really uses the indexes. However, I guess you'd like to know that before creating indexes, especially when you have to wait for a long time to build indexes. If you use this function, you know if Postgres will use indexes or not beforehand, with no need of creating any indexes. So hypothetical indexes can help index design tuning. The next major version, HypoPG 2, will start supporting hypothetical partitioning for Postgres 10 and above. It allows users to try and simulate different hypothetical partitioning schemes on real tables and data. And then it outputs create plan and a cost with explain statement using these defined hypothetical partitioning schemes. So hypothetical partitioning function will help partitioning design tuning in the same way as hypothetical indexes. Next, I'm going to talk about the reason why we are working on hypothetical partitioning function. You know, declarative partitioning was introduced in Postgres 10, and it was a long-desired feature. In the previous Postgres versions, partitioning was realized by combining the function of table inheritance, check constraints, and trigger function. Accordingly, it's necessary for users to understand the all three functions to realize partitioning. In Postgres 10, partitioning is realized by just typing create table and some partition expression. So users can use partitioning much easier than ever. Also, performance of declarative partitioning is much more improved than that of inheritance-based partitioning. Moreover, in PostgreSQL, partitioning is further enhanced. I cannot list all of them, but for example, hash partitioning, partitioned indexes, default partitions, update row movement, and so on. Also, first partition pruning, partition-wise aggregate, and partition-wise join will be introduced to improve query performance on partitioning. Postgres partitioning will be further improved with new Postgres versions. By the way, the most important factor affecting query performance over a partitioned table is partitioning schemes. That is, you have to consider which table to be partitioned, strategy to be chosen, and columns to be specified as a partition key, and how many partitions to be created. Conversely, if you define an optimal partitioning schemes for your queries, query performance can be improved dramatically. However, the optimal partitioning scheme depends on your query and which benefit you want to earn by partitioning. Let me give you some examples. At first, I'm going to talk about the case when you want to earn the benefit of partition pruning. Partition pruning is a state that do not scan unnecessary partitions according to where condition, just like this example. In this instance, 1 out of 12 partitions is scanned according to the condition date is equal to January. Data size too big read can be reduced by this feature. Therefore, query performance is improved. In this case, an optimal partitioning scheme is partitioning a table by the column specified in where clause. In this instance, the date column is specified in where clause, so when partitioning the orders table by the date column, partition pruning works well. Otherwise, you result in scanning all partitions. Next, I'm going to talk about the case when you want to earn the benefit of partition-wise join. Partition-wise join is a technique that joining pairs of partitions and they have this similar partitioning scheme, just like this example. By this feature, join queries might be faster than joining large tables. In this case, an optimal partitioning scheme is partitioning a table by the column specified in join on clause. In this instance, both customer ID columns are specified in join on clause, so when partitioning the orders table and the customers table by the customer's ID column, partition-wise join works well. Otherwise, you result in joining on large tables after scanning all partitions of the orders table and the customers table. At last, I'm going to talk about the case when you want to earn the benefit of partition-wise aggregate. Partition-wise aggregate is a technique that performing aggregation per partition and combining them just like this example. By this feature, aggregate queries might be faster than performing aggregation on large table, like partition-wise join. In this case, an optimal partition scheme is partitioning a table by the column specified in group by clause. In this instance, the date column is specified in group by clause, so when partitioning the orders table by the date column, partition-wise aggregate works well. Otherwise, it results in performing multiple aggregates, that is, partial aggregates on each partition and final aggregate. So far, I've explained some benefits of partitioning separately. But how about this situation? When you have some queries which access the same table like this example, if you partition the orders table from the perspective of partition pruning, you will partition this table by the date column. On the other hand, in terms of partition-wise join, you will partition this table by the customer ID column. I guess you want to decide the partitioning scheme after checking actual queries behavior on different candidate partitioning schemes. Just like this situation, there are often multiple choices on partitioning schemes because you have many kinds of queries and tables. And what is worse, actual partitioning and unpartitioning of tables takes a lot of time, so you will waste time on trying multiple partitioning schemes. Also, query plan and cost are largely affected by data size and parameter settings. Considering is one thing, doing is another, so deciding an optimal partitioning scheme is very hard. So I wanted to ask you this question. Do you want to know how your queries behave before actually partitioning tables? If yes, I recommend you hypothetical partitioning. It helps you to decide the optimal partitioning scheme. By using this function, you can quickly check how your queries behave if certain tables were partitioned without actually partitioning any tables and wasting any resources. Also, you can try different partitioning schemes in a short time. That's why we are working on hypothetical partitioning function on HypoPG. Okay, next, let me talk about the usage and the architecture of HypoPG. At first, I will explain how to create hypothetical partitioning schemes. You need to have an actual plain table to be partitioned hypothetically. You can create hypothetical partitioned table using HypoPG function, HypoPG partition table function. You only need to specify the target table name as the first argument and the partition by clause as the second argument. Also, you can create hypothetical partitions using another HypoPG function, HypoPG add partition function. You only need to specify the hypothetical partition's name as the first argument and the partition of and the for valued clause as the second argument. If you want to define multi-level hypothetical partitioning, you could just specify the partition by clause as the third argument. Even though both functions require apostrophes to specify each argument, you now notice that these functions work in a similar way as create table statement. After this process, hypothetical partitioned table and hypothetical partitions are not stored in any catalogs, but in the backend local memory. Also, these tables don't have any data, so you don't need move data to partition tables. HypoPG needs statistics of hypothetical partitions for correct estimate. As I said, hypothetical partitions have no data, so we prepare a function, HypoPG analyze, to create hypothetical statistics, hypothetical partitions. You could specify the target table name as the first argument and the percentage of sampling as the second argument. As for sampling, I will explain later. The target table specified in the first argument must be a root table. After that, statistics of all leaf partitions that are related to the given root table are created in every column. Items of statistics are most of common values, histogram, distinct values, and so on. In short, these items are same to those created by analyze command of Postgres. I will explain how HypoPG analyze function works using this example. The orders table is partitioned by the date column hypothetically, and the partition of which date is January has two hypothetical subpartitions split by customer's ID column. In this case, you have to write HypoPG analyze function like this. Of course, you can modify the second argument as you like. At first, it gets a partition bound for each leaf partition. The partition bound includes ancestors, if any. In this case, the partition bound of top one is date is equal to January, and customer's ID is between 1 and 1,000. Next, it generates a where clause according to the generated partition bounds. So where clause is also date equal to January, and customer ID is between 1 and 1,000. Then it gets sample data from the root table using table sample clause. Table sample clause gets sampling data from a target table according to user-defined percentage. Current Postgres supports two options, system and Bernoulli. System option picks sampling data by the page, and Bernoulli option picks sampling data by the row. Users can use table sample with where clause. If there are where clause, it eliminates sampling data that didn't satisfy the where condition. Okay, let's get back on track. The percentage, which is specified as a second argument of HypoPG analyze, is used in table sample clause. So in this case, 70% of data are picked up from the orders table. Also, it eliminates sampling data according to the generated where clause. After that, it computes statistics for sampling data in every car. Okay, now I will explain HypoPG architecture. For hypothetical partitioning function, HypoPG uses four kinds of hooks. The aim of hooks is to interrupt and change the usual behavior of Postgres. It allows developers to add new features without the need to adding it to the core. At first, when Postgres recognizes explain statement, HypoPG detects an explain without analyze option and saves it in a local flag for following steps using process utility hook. By doing this, partitioning schemes are displayed only when typing explain. Next, when Postgres gets relation information from the catalogs, hypothetical partitioning schemes are injected into Prana according to the table OID if the target table is partitioned hypothetically by using getRelationInf hook. Also, when Postgres gets statistics to compute selectivity, hypothetical statistics are injected into Prana as well if they are created in advance using getRelationStats hook. By creating hypothetical statistics, HypoPG estimates hypothetical partitioning correctly. At last, using executor and hook, explain flag is removed. And finally, HypoPG shows queries plan and cost using hypothetical partitioning schemes. By hypothetical partitioning function, you can simulate range and list and hash partitioning and simulate partition-wide partition pruning, partition-wide join and aggregate, and anyway join and parallel queries. Also, you can simulate multi-level hypothetical partitioning, and you can simulate both actual and hypothetical indexes on hypothetical partitions. On the other hand, there are few limitations. For example, it supports only print tables and only select queries because current Postgres doesn't have suitable hooks to simulate already partitioned tables and update queries. Also, it doesn't support Postgres 10 yet. So let me guide you through the hypothetical partitioning by a demo. Imagine these two simple tables, the customers table and the orders table. These table definitions are like this. In this demo, I will partition the customers table actually and partition the orders table hypothetically. Also, I will execute some simple queries on them. sorry. Okay. Yeah. I've already installed HypoPG on my database. And you can check it easily using meta commands. First, let's create test tables. I create the customers table and partition it by customers ID ranges like this. Also, I add 3 partitions to the customers table. The range of customers 1 is between 0 and 20,000, and 2 is 20,000 to 40,000, and 3 is 40,000 to 60,000. Then I insert data into the customers table like this. Okay, 60,000 rows were inserted. Next, I create the simple table, hyperordered table. It will be partitioned hypothetically later. Then I insert data into this table like this. Okay, 300,000 rows were inserted. And I run vacuum analyze. Now I execute simple queries which scan each table. Okay, as you know, query plan are like this, and the hyperordered table is not partitioned hypothetically yet. So, of course, just one sequential scan is displayed. Okay, next, let's create a hypothetical partitioning scheme. At first, I partition the hyperordered table hypothetically using HypoPG partition table function. By typing like this, the hyperordered table is partitioned by customers' ID ranges. As I said, you cannot partition hypothetically an already partitioned table, so if I specify the customers table in the first argument, the error is occur like this. Okay, next I add 3 hypothetical partitions to the hyperordered table using HypoPG add partition function. The range of hyperordered 1 is between 0 and 20,000, and 2 is 20,000 to 40,000, and 3 is 40,000 to 60,000. This function returns 2 columns. One is the object identifier of hypothetical partitions, and another one is generated hypothetical partition's name. Just like this, I partition the hyperordered table hypothetically in the similar way as the customers table. Okay, you can check existing hypothetical partitioning schemes using HypoPG table function, like this. This function returns 6 columns, the object identifier of hypothetical partition's name, and its parent and root tables level ID, and partitioning schemes. Partitioning information. Okay, next, let's compute the statistics for the hyperordered table. By typing like this, HypoPG computes statistics using 50% of data got from hyperordered table. After that, hypothetical statistics of all if partitions, that is, hyperordered 1, 2, and 3 are created in every column. Okay, let's check the hypothetical statistics. You can check it easily using HypoPG stats view, like this. You can access this view in the similar way as PG stats view like this. Okay. And I will execute some queries on this table from now on, but before that, I prepare the ordered table, which is an real partitioned table so that we can compare query results of hyperordered table and ordered table. I've already created the ordered table and its 3 partitions, like this. The ordered table is partitioned in the same way as a hyperordered table. So I insert into the ordered table from hyperordered table. Okay, and then I run vacuum analyze. The ordered table has same partitioning scheme and data as hyperordered table. So you know the query plan and cost on the ordered table are ideal for the hyperordered table. Okay, let's execute simple select queries again. I created hypothetical partitioning schemes for hyperordered table. So if I execute this query, which scans hyperordered table with explain, you can find that hypothetical partitions are displayed. So you notice that HypoPG uses created hypothetical partitioning schemes. HypoPG displays both original table's name and hypothetical partition's name. Okay, to confirm the query plan on the real partitioning, I execute the similar query on the ordered table. By comparing these plans, you know that the query plan using the hypothetical partitioning scheme is correct. Besides that, estimated cost and rows are almost correct as well. Yeah. Okay, as I said, hypothetical partitioning scheme is not used with explain analyze. So if I add analyze to the query plan is like this. Okay, you can also simulate partition pruning as well. So I execute this query, which scans the hyperordered table with a where condition the customer's ID is smaller than 20,000. Like this. The only hyperordered one is scanned. And I execute a similar query on the ordered table. The query plan and cost on the real partitioning is similar as that on the hypothetical partitioning. Next, let's check partition-wise join. I execute this query, which joins hyperordered table and the customer's table with the join condition hyperordered customer's ID is equal to customers. For now, both tables are partitioned by customer's ID column, and their partitioning schemes are similar, so partition-wise join works like this. Also, I execute the similar query on the ordered table and the customer's table. The query plan and cost on the real partitioning is similar as that on the hypothetical partitioning scheme, like this. Next, let's check partition-wise aggregate. Okay, I execute this query, which performs aggregate function on the hyperordered table. For now, the hyperordered table is partitioned by customer ID columns, so partition-wise aggregate works like this. Also, I execute a similar query on the ordered table. The query plan and cost on the real partitioning is similar as that on the hypothetical partitioning, like this. Okay, now let's try a different partitioning scheme. But you cannot partition hypothetically a table which is already partitioned hypothetically, so the error is occur, like this. So at first, I remove existing hypothetical partitioning scheme using HypoPG reset table function. You know that created hypothetical partitioning schemes are removed using HypoPG table. Okay, let's try again. I finally create new hypothetical partitioning scheme like this. The new one is partitioned hypothetically by the date ranges. And I add these hypothetical partitions, which are split every quarter. Okay, and I check the new hypothetical partitioning schemes. And also, I compute the statistics on the hyperorders table again. Okay, now let's execute some queries again. I execute this query, which scans hyperorders table. You can see the 4 hypothetical partitions. And I execute this query, which scans the hyperorders table with where condition the customer's ID is smaller than 20,000. Yeah. You can find that all hypothetical partitions are scanned with this where condition. Partition pruning doesn't work because the hyperorders table is now partitioned by the date column. On the other hand, if I execute this query, which scans the hyperorders table with where condition the date is newer than 1st of October, partition pruning works like this. Yeah, just like this. By using the new HypoPG, you can simulate and try different partitioning schemes in a short time without actually partitioning any tables. Okay. Okay. At last, I will talk about our future works and summary of this presentation. Our next steps are as follows. We will support Postgres 10, and we will propose to have a better integration in Postgres core so that we can support update, delete, insert queries, and already partitioned tables. Also, we will add automated partitioning advisor function. For now, hypothetical partitioning features only simulate partitioning schemes, which users considered and defined manually. But I will enhance this function so that it automatically search and propose an optimal partitioning scheme in the future. Okay, let me summarize the main points of my presentation. HypoPG 2 will support supporting hypothetical partitioning function. It allows users to try and simulate different hypothetical partitioning schemes on real tables and data. And then it outputs query plan and cost with explain statement using hypothetical partitioning schemes. By using this function, you can quickly check how your queries would behave if certain tables were partitioned without actually partitioning any tables and wasting any resources. Also, you can try different partitioning schemes in a short time. So hypothetical partitioning will help you all to design partitioning schemes. HypoPG 2 is still under developing, and we would be happy to have some feedbacks. Okay, that's all for today. Thank you for listening. If you have any questions, but please, read this text. Yeah. And also, if you have complicated questions, please send me email. This. I'm really sorry. Okay, yeah.
You know about how long this will be, when this will be released?
How long?
How long till this
Okay.
version 2 is released?
The date of release?
Yeah.
Okay. Yeah, the date is undecided yet, but I want to release the first version according to the timing of Postgres 11 release.
Okay.
Yeah. Thank you. Yes.
How many people are working on HypoPG? How many contributors do you have?
As for hypothetical partitioning, 2 people. Yeah. Thank you. Any questions? Nothing? Maybe. Okay. Please send me an email. Okay. Thank you for coming today.